So the first thing I'd like to do is to go through those questions and yeah.
Can we turn it off?
Hold on a second. So first of all, as much as possible, go through the questions on questions set 1 and 2. And I would like to also give you just a brief overview on the entire course. And for any remaining stuff, we will either have another session, or I will try to respond to you, in a audio-visual format, or some kind of web conference. Okay, I want to make sure that your time is used in a very efficient manner. Now, with some of these questions, what I would like to do, actually, is for us to do it together. And the way we can do that is, okay, let me just pause this for a moment. You don't really know. So here the negative scalp means you have a negative position. And you don't know. So whichever way market swings, okay, actually if you have a negative option, if you are short option, it's like that. And you try to hedge it. And you know that whichever way the market swings, you will have some kind of a loss. This is the negative scalp. Okay, now to work that out, so it implies at the back of that there is actually a delta hedge to it, or it's delta neutral. This is kind of like, this is the counterpart of the question above, where this one is ex ante, if you like. You know the difference between ex ante and ex post, right? Ex ante is what happens before you know the outcome, and you are trying to predict. So ex post is so it's already happened, so now you try to count the gains or the damage, okay? So here you simply apply the formula, a half gamma ds all squared, which will be a half times 200, because you are short 200 gamma, okay, times ds squared, which is square of 1, okay? What is the square of 1? The square of 1 is 1, okay? Remember that, okay? So this should be 100, okay? Everyone is okay? Yeah? Now, I'm not going to ask you, I wanted to start off with question 1. I'm not going to ask you to do every question. We probably do not need to, and we don't have time for that. So I will ask you to do I think the more challenging ones. Now, this one, I purchased the, just shut that down. Okay, I'm still live, which is good. I purchased the put that little clock there. Okay. Just to give you a tip. So today I may actually talk a little bit fast, and if there's some place you feel you are lost, or you don't completely understand, or you want to go back, have a look at that little clock. And you make a note yourself, because this will become a video later on, and then you can just go back to that time segment, and you don't have to listen to the whole thing again. Okay? Yeah. So you can do that. Okay, so this little clock will be down here. Okay, now I purchased the November 60 call. Now the 60 is the strike, and I sell the September 60 put, and share price is currently 60. There is no dividend, but there's a little bit of interest. So am I gamma long, delta long, Vega long, delta long, or gamma long, Vega short, delta long, gamma short, Vega long, delta long, or gamma short, Vega short, delta long? Which one do you think it is? I think this question is actually worth doing. All right. Now, what you have here, that if you see, when you see a question like that, I can just show you step by step how I might react to it. The first thing is you are long a short-term call and you are short a long-term put. Number one, okay. So you are short, you are long a shorter term call, and you are short a longer term put. Number one, okay. Number two, these options are basically at the money because the share price is now 60, and there's no dividend paid. Now, let's try and look at these one by one, okay? And then when you hear me tell you about this, you will understand why these questions are such good exercises for you to get a good understanding. So now I'm long. First of all, I'm long the November call, and I would like to have a look at their gamma behavior and their Vega behavior, and also their delta behavior in that order, because that's how the answers are presented, okay? And also I am short a December put, okay? Now, the first thing to remember is that when you have, this is a short-term option, and this is a long-term option, and both of these are at the money. Now, when an option is short-term, the gamma is actually higher than the gamma of a long-term option when they are at the money or near the money anyway, okay? So let's say here, and the way I like to do these questions sometimes is, instead of just sitting here and thinking in abstract, I like to try and put some sort of imaginary numbers to them. Okay, so I just say, okay, how about if the gamma here was 7? Okay, doesn't have to be 7. If you want it to be 15, 25, whatever, okay, I'm just going to put a number there, okay? Now, the reason I do that is I know that for a longer term option, the December option, the gamma will be less. So let's say it's 5. Let's just say it's 5, okay, or 4 or 3, okay. And I am short this option, so I know I'm going to be short this gamma also, okay. So on a net basis, I will be. So if you tally it up, so total position, okay, I am long gamma. So immediately I can eliminate answers C and D, because only A and B are long gamma. Okay, now I might even, I think at this stage it's worth explaining to you. I just told you that if an option is short term, then the gamma is higher, and you might wonder, well, why is that so? Okay, now let me try and give you an idea. Okay. Now, so let's say this is the December option, and this is the November. Now, I know that we are talking about calls and puts, but it doesn't matter, okay? There is a certain symmetry. Now, gamma really is measuring the speed at which the delta, so delta here equals to 0, and delta here equals to 1. Now, gamma is measuring the speed at which your delta is changing from 0 to 1. And you can tell just by looking at, let's say, this section, okay, eventually, for both options, the deltas have to go from 0 to 1. But when you are here, you can change that, you can see that the delta here changes faster. And the reason it changes faster is if you just take out these two curves, one of them looks like this, okay, but the other one looks like that. So it starts quite flat, and then it catches up. So here there is actually more sort of curvature, or the correct term is actually convexity. Okay, so it's more convex. In other words, it's changing speed faster. So the delta here changes faster. So as a result, so that implies that the gamma has to be higher. Now, if that still doesn't grab you, when you refer back to, that's why I said this is probably one of the most useful pages in the whole course. Okay, these graphs are telling you exactly that. And the one to pay attention to is the middle one. Okay, so you've got the blue line is a short-term option. The blue line is a short-term option. Oops. And the short-term option, the gamma actually is higher, substantially higher than a long-term option, but they actually cross over. So let's say at the around the 5% point. So if there are two options and they are both either in the money 5% or out of the money 5%, that's when their gammas will be approximately equal, and then the relationship will switch to the opposite. Okay, so that question is actually utilizing this very simple insight. Okay, now for Vega, Vega is a simple one because all things being equal, when you have a long-term option, the Vega should always be higher than the short-term option. Vega is measured like this. So when you have an option and you are around here, so this is the amount between the option value and this amount here is what's called the time value. As I'm sure you know that time value, and this is kind of like the juice or the meat of the option. So when you are here, let's say, okay, so this is the entire option value, but actually this part is the time value, and this part, as you know, is called the intrinsic. Now, intrinsic isn't really so interesting. It's just, you know, I take $5 from you because I'm going to pay you $5. It's money in, money out. The time value is what determines how much Vega you have. Okay, so the thicker this part, so the more time value, or time premium as it's sometimes called, time value, the more time value, the higher the Vega. Okay, so obviously for a long-term option there will be more time value. So let's say I call this 17. Okay, And then for the short-term option, I will call that 13. Now I'm just making these numbers up, but then because I'm short this one, so the Vega would have a negative sign in front of it. Okay, so on a net basis, I am short Vega. Okay, now we don't know if it's 13 or 17. It doesn't matter. When I put some real numbers, I can relate to it, and I find it easier to work with. Okay. And then if I am long a call, then I am long delta. So this would actually be approximately 50 delta. And when I'm short a put, I'm also long delta. So on a net basis, I'm totally long delta. Okay. So B is the only one that fits the bill. Everyone is okay? Yeah? So this is how you would work it out. Now, let me go to question 4. So here I purchase the November 65 call, and I sell the November 70 call. Okay, so first of all, I'm long a call and I'm short another one. Now the time, the maturity is the same, and they are both out of the money because the Hutchison now trades at 62.50. Okay, now that's important. So you've got two out of the money calls, and let's look at it like this. Okay, so I am long the November call strike 65, and I'm short the November call strike 70, and I would like to think about their gamma characteristics as well as their Vega characteristics. Now, as I said before, I am going to make up some imaginary numbers. Okay. The first thing I know is that now again, the best way is if you refer to this graph here. Okay, so the gamma of, now we don't have different maturities to consider. Okay, it's just one maturity. The gamma of an option that is at the money is the highest, and when it's near the money, it decreases, but the further out you go, the gamma actually would decrease. Okay, this is actually just another way of saying, Timo, hang on a moment, okay? This is another way of saying that as you start going up or down the price function, the speed of the delta change is actually slower and slower. So here, delta changes not a lot. It may start at 0 and then it becomes 0.001. Here it's just 1 at the other extreme, and it changes very slowly back to 0.999 and 998 and so on. It's actually when you are right in the middle, that's when things are happening very fast. That's what that's trying to say, okay? Yes, Timo, yes.
I have one question. Why can you say the both calls are out of the money? Because I'm the 17 call short. So I would say if the options rates above 70, I'm out of the money. Below, I'm in the money for the short call.
Okay, now, first of all, regardless of whether you are long or short, so for the 65 call, if the market is 65 or above, okay, then your 65 call is in the money. In the money means this option will pay something if you were to exercise it. Now, it's the same actually for the 70. So if the spot price was more than 70, that implies and now it is not, okay? That implies the 70 call is in the money. So anything other than that means that the options are out of the money.
But it's the other way around when I'm short an option. I mean, that's the case when I'm
I see what you mean. No, it doesn't work like that. The way you think about in the money or out of the money, okay, is independent of ownership. Okay, you just look at the option. You look at the option. Okay, there is. I don't want to say I have an option or you have an option or I buy or I sell. There is an option. Okay, look at that. Think of it like there is an option, and the option has a strike of 70. Okay, now if it's a call, that implies that if the share price is above 70, then this option is in the money, and therefore it's good for buyer or good for the long party and bad for the seller. I think this is where maybe you got a bit mixed up. Okay, so this is actually the last step. Now, if the option or if the stock price is, let's say, 50 right now, okay, now that implies the option itself is out of the money, and whether when you want to determine if an option is in the money or out of the money, it has nothing to do with whether you own it or whether you buy or sell. It's just you look at the option itself, okay, and then you think, okay, it's out of the money, so that's actually bad for the buyer, and good for seller, okay, but it's still out of the money. Yeah, are you with me then?
Yeah. So because you don't take into account whether you are short or long, you just go whether it is call option or.
Correct. Exactly. Yeah. You're right. You're right. What you just said. Okay. It's okay. Now, so what I want to do now is, so I just told you that the gamma of a, now you can say this is what I sometimes call near the money, although this term is not really used so widely compared to ITM and OTM, and the 65 call is actually nearer the money than the 70 call, okay, but they're both out of the money. So I know that the gamma of this one would be higher. So let's say I give it 7, then the other might be 3 or something, okay. Now because I'm short this option at a strike 70, so I know that the gamma here needs to be negative. But on a net basis, for the total, I'm still long gamma. So I know the answer has to be A or B, just purely looking at that. Okay. Now, if you look at Vega, so there are two options, and one of them is a little bit out of the money. So strike 65. And the price of the stock now is 62.5. Now the other one is actually a bit more out of the money because it strikes 70, and the price is now 62.5. Okay. Now, if you want to know how sensitive an option's price is to movement in volatility, all you got to think about is how much meat there is here. This is the time value. So the more time value, or sometimes called time premium, and it's sometimes called optionality. So there are a lot of different names. Okay. So when these are high, then the Vega value would be high. Okay, so of course for the option which is strike 65, there is higher optionality. So this one, maybe it has a Vega of 13, in which case this one might have a Vega of, let's say, 9, okay? But it'll be minus 9 because you are short. So on a net basis, you are both long gamma and long Vega. So A is the correct answer. Okay? Everyone is okay? Now that is why I like putting numbers. These numbers have no mathematical basis whatsoever. They just help me visualize. They help me relate to the final result. Okay? Now I want to speed up a bit. Now here I purchased the January 2012 1800 call in the Hang Seng Index, contract size 50, and I sell 10 times the January 2012 60 call in Hutchison, contract size is 1000. Now this is a bit funny. Like I said, in the United States, all option contracts are traded with a lot size of 100. So one option contract means you are buying or selling options for 100 shares. For Hong Kong, the convention is rather confusing. So here you may be trading in the Hang Seng Index with a contract size of 50. So that means that for the Hang Seng, the actual value would be 1800 times 50, which is $900,000. Okay. Now for the Hutchison, for the Hutch, it will be so you got 10 contracts, and then the strike is 60. And then the contract size is, one contract is 1,000 shares. So this becomes 600,000. Okay. So when you look at the answers, and I want to emphasize here again, I have said this before, when you do the final exam, sometimes some answers may look vaguely acceptable to you, but always pick the answer that is the best one. Okay. Here it says A, I'm Vega flat as both options are at the money. Well, you don't know that. They don't tell you anything about the spot price. Okay. I'm Vega short as the contract size of the Hutch option is larger than Hang Seng. Well, that's clearly not right. Because it's less. So C is the only really remaining answer that is correct. Okay. Now for question 6, so I purchased the January 2012 1800 call in the Hang Seng, and the index right now is also 18,000, I'm sorry. Okay, so it's at the money. You're long that option and you are long gamma, and the gamma is 0.001. Okay. I sell 10 times the January 2012 60 call in Hutchison. And Hutchison trading at 60, and the gamma is 9. Okay. Now, the problem here is you can get what I call a dollar gamma. Now the dollar gamma revenue, of course you know by now how to work that out. It's a half gamma times the square of the price. So for example, for the Hang Seng, okay, the gamma would be a half times 0.001 times, let's say there's a 1 point change in price, so this will be 0.0005, and then the Hutch, the dollar gamma would be a half times 9 times 1, or the square of 1, okay, so it's 450. Now, first of all, what have I shown you here? What I am showing you is if the Hang Seng moves up by 1 point, there will be gamma revenue equal to very little, okay, is not even half a cent, is 0.05 of a cent. Whereas if the Hutch moves $1, the gamma revenue would be $4.50. Okay. Per option, I mean per share. Okay. So this isn't really very useful for traders, because a 1 point move in the Hang Seng is very, very different from a 1 point move in from a $1 move in Hutchison. A 1 point move in the Hang Seng represents a move of 1/18,000, whereas a $1 move in Hutchison is 1/60. So that's actually more than 1%. So this question is asking, what if? The question is, if I normalize my position to $100 stock, what would my position be? Now, this is another way of normalization. Normally means you try to scale everything back to 100, which is a pretty neat number, okay? So in other words, the question is asking, what if we don't think in dollar terms, but both of these actually move by 1%, let's say 1%, okay? That's what normalizing means. Now, for the Hang Seng to move 1%, that means it moves 180 points, okay? So the gamma of that will be a half times 0.001 times 180, and you square it, okay? Now, for the Hutch to move 1%, that means, now first of all, you have 10 contracts, okay? And then it's a half times gamma times 1% for the price of Hutchison is 60 cents, and you square that, okay? Now, if you do the calculation for both, you would realize that they actually both come to 16.2, okay? But you are long this one and you are short this one, so therefore you are gamma flat, okay? I would love to have you guys actually do this question right in front of me. I am so sorry. I just do not have the time the way we are running things, okay? I would love to have you do it, and then you tell me if you got the right or wrong answer, why you think that's the right or wrong answer. But I think today I better just get this all covered as a priority, okay? But do you understand what I just said to you? Yeah? So normally for these, when you are given a gamma parameter, it's very, very handy for you to work out what happens when the price moves by $1. But now, because you are comparing apples and oranges, telling me that something moves by $1 is not really very meaningful. So I want to know what happens when both things actually move by 1%. Okay? Now, traders would do that quite often, because for them, it's not whether it moves by $1 or $2 or $5, it's whether there's a 1% move. Okay? Now let me let me go to, I'm going to go up to, I'm going to try and finish this up to question 9, and then I'll go back and we have a look at question set 3, okay? Now, for question 7, the October 65 call in Hutchison is trading at $2, and the Greeks are as follows. So delta 35, so that means when the spot price changes $1, okay, then the call option price will change by 35 cents. That's what that means, first of all, okay? Approximately, okay? But actually this is not, or the delta part at least, okay? This is actually not entirely correct. So we have a call option, and then the price changes. It goes from, let's say this is the change in the stock price from here to here, and your option price changes. So there will be two parts to it, this part and this part above it, okay? And I'll show you how to work these out. Now, to do this question, so you got gamma and you assume it doesn't change, and you got Vega and you assume it doesn't change. The share price goes up by $1 and volatility goes down by 2 points, and you just ignore theta for now. So you assume that is some kind of instantaneous price change, and here is where the idea of average delta that I mentioned to you is very useful, okay? Now, first of all, let's work out the change in price. So this is not strictly correct. The change in price is equal to the average delta multiplied by the change in price. Now, what is the average delta? Average delta is equal to the old delta plus the gamma times the change in the share price. Now, this should not be something new to you, because I told you that, I think, in either the first or the second session. Okay, sorry, average delta. The reason this works is that because after all, gamma is equal to the change of delta when the price changes. So if you multiply that by the change in price, okay, what you end up is you do get the change in the delta. So to cut a long story short, the average delta would be the old delta, which is 35 plus gamma, which is 2, and then the price change is 1. Okay, so what am I saying? This is the new delta. I beg your pardon. Okay, the new delta. The new delta is the old delta plus the change in delta. Okay, this is the change in delta. Change in delta. So the new delta is 37. That is saying that if this is the old delta and now the price rises to here, there is a new delta value. So this one is 35, delta 35. So here it will be delta 37. So the average is actually 36. Okay, so average delta, average, is 36. Okay, so Now the share price moves $1, so that means, so the share price goes up $1, so that implies that your option price is gonna change by 36 cents. And as an approximation, you actually can do that for short-term, moderate movements. And once you work out you can't use the old delta, you can't use the new delta, but you can use the average delta. Okay, so 36 is a gain. Okay, but they also tell you that volatility has dropped by 2 points. Now, if it drops by 1 point, then you are going to lose 10 cents. And if it drops by 2 points, you will lose by 20 cents. So the vol goes down by 2%. So that implies that there is a well, this is the change in the call price due to delta. So there's a change in the call price due to the Vega factor, which is minus 20 cents. Okay, so that's a loss. So on a net basis, you have a gain of 16 cents. Okay. So therefore, the option price goes from $2 to $2.16. Okay, so C is the right answer. Okay. Now, for question 8, I have the following option portfolio. So I'm delta flat, I'm gamma long and Vega long. And volatility right now is 32%, and share price is $5, and the share price drops by 15 cents, and volatility drops by half a point. My daily result, including all components, are as follows. Okay, now let's take a look at them one by one. Okay, so who are the key members of the crazy Greek family? Okay, so there's delta, there is gamma. Okay, now delta, they already said you are delta flat, so you get nothing from there. Okay, now for gamma, it will be a half times gamma, which is 200,000, okay, times the square of the price change, which is the square of 15 cents, and that is equal to a gain, because you're long gamma, you will always gain 2,250. Okay, so you have is that right? 100K times, yes. Okay. And then now for the Vega, did anything happen to Vega? I think something did, because volatility dropped. Thank you. Volatility dropped by 0.5%, and do they give you the Vega? Yes, 2,000 Vega long. So you are going to have a price change or a value change of 2,000 times, but it's minus a half because it's gone down. Okay, so here you are going to lose $1,000. Okay. Now the last thing, they also want you to work out what theta is, and for that you just use. Okay, if I was to list out the formula, so first of all, nothing for delta, and for gamma revenue, is just a half gamma ds squared. Okay, now Vega is just a straight multiplication. For theta, you need to work out what is the time decay. So that's a half gamma. So like I have said 3,000 times, okay, this one is exposed. What actually happens, and this one is what is predicted by theory or the model or ex ante. Okay, it's a little bit like, you know, the analogy would be you use a model, whether it's CAPM or APT, so that would be ex ante, and then after the event you find out exposed, there's some alpha, so the answer is different. Okay, so that would be exposed. So here, if it's a half gamma times sigma s all squared, so that is a half times, and this is a loss, by the way, because time is always running against you. If you are long options, and I know you are long options because you are Vega long and you are gamma long. Okay. So this will be a half times 200k times. Now what is sigma? Sigma is 2% for 1 day. So 2% times the share price, which is $5. I knew the share price would be applied somewhere. So this is actually, what's 2% of $5? 10 cents, okay, or 0.1. So this becomes a half times 200k times 0.1, or the square of 0.1 rather, okay. And you find that this is actually, what is that? So 0.01 times 100k is 1k, isn't it? $1,000. Okay. Now all you got to do now is like shopping in a supermarket. You just tally them up, you itemize them. Thank you very much. This is your invoice. Okay. And in fact, there is a net gain of $250. Now it's very important for you to understand how I arrived at the answer, because I suspect there will be some questions like this in the exam. I don't mind telling you, because that's what you've been learning for the last 10 weeks, okay? So just be aware of not so much the answer, but how I arrived at the answer, okay? Now, I'm going to have a look at this one, and then I'll give you a short break, and then we'll come back. My option pricer showed me the following. I am short delta, so share price of something, I don't know what it might be, could be Hutchison, could be HSBC, is 65. I'm short delta, I'm long gamma, long Vega, okay? Now, my first reaction when I look at this, I ask myself, what kind of option can this be? Okay, that's the question that I ask myself. What kind of option do you think this can be? If I have an option, one option, and I have a short delta, I'm long gamma and long Vega. Very good. Very good. Yeah, someone says long put. You are, okay? Because when you are long put, you have a short delta, you have a negative delta. And if you are long options, any options, okay, you are long gamma and long Vega. Now I would add even one more point. You are actually long a slightly out of the money put. And how do I know that? the delta gives me the clue. Okay, if a put is in the money, it should be somewhere around. It should be more than negative 50. Let's say 55, 60, negative 70, whatever. Okay, if a put is slightly out of the money, it would be like minus 45, minus 40, all the way down to 0. Okay, so now I know this. I just end up making my life a little bit easier, because without even looking at all that stuff at the bottom, I know that I'm looking at an option, something like this, and I'm kind of somewhere here. Okay, so this may be a put option, let's just say, okay, with a strike of 60, and the spot price now is 65, and I'm right here. Now, with that information, you make life a lot easier for yourself. So that would be, okay? And then what you say is, I now raise my implied volatility and recalculate. Okay? Now, the effect. Now, you remember I told you earlier that all things being equal, when an option is just losing time. So this the top one is a long term, this one is a short term. When an option is just losing time, I've drawn this very badly. All right, I really have to do this. When an option is losing time, it will gradually sink back down to earth, and it would gradually, and then the next step is it would do this. My hand is not shaking. I have not been drinking. Okay? It's very hard to draw these things. Yeah. Okay. So these curves will start to sink when time passes. Now, that's the first observation. The second observation is when volatility decreases, that also happens. Okay? So if suddenly volatility goes down, then the whole curve will go down. Now here, what they're saying is you raise volatility, so it's actually going the other way. Okay? If you think of it like this, so like I said, this is the long term. And there's a short term. So how do you go from the short term to the long term? You can imagine if you were pulling this, if you were pulling at both ends, that's the kind of result you get. Okay? Now, what is the characteristic of these two lines? The way you can think of it is as follows. Okay, so the question I want to ask is, what happens when volatility goes up? So because you raised your volatility. Okay. Now this is an out of the money put. Okay, so like I said to you before, when volatility goes up, so your curve is now, it is starting to sort of levitate, is the word, is leaving the ground and is rising. And in that case, for an out of the money option, your delta would actually increase. So let's say if the delta before was minus 40, okay, it would now be minus 42. When I say increase, I mean the number would be higher, okay? So the answer has to be either A or B, okay, because the delta or the absolute value of delta goes up. And if you're wondering where did that come from, well, I think I would have summarized that for you somewhere. Here you go. These pages. Let's get rid of this. These rules that I was telling you, okay? The delta of a short-term option is less than the delta of a longer-term option, but also for Vega, when you increase the vol, it has the same effect as if you are pulling the curve up, and then the delta change would accordingly it gets steeper, in other words, okay? It gets steeper. So from here to here, it's steepening. Okay? Now, as for gamma, what happens to gamma when the curve is rising? Well, like I said, when your curve is very close to the baseline, like this one here, okay, then actually your delta is changing very fast and your gamma is very high. So when it's actually rising, when it's going in the other direction, the speed of delta change actually slows down. So gamma will go down. And then when you increase volatility and the curve is leaving the base and getting further and further away, so that means there is more optionality here, okay? So as a result, your Vega will go up. Now, as you can see here, of all these choices, there is only one that fits this profile. It's certainly not C and it's not D, because the delta has gone down, or the absolute value of delta. Now for A and B, we need gamma to come down. So A is the only correct answer. And in fact, we need Vega to go up. So this also fits the bill. Okay? Is everyone okay with that? If not, you can go home and hopefully when you listen to this segment, you will get the idea. Now let me just stop it here for a moment, and I will be back in 5 minutes. Okay, and then we'll go through the other segment.